Okay, so we are going to talk about TLS connection. How does client authenticate the server certificates? How does key exchange happen? And how does the data start flowing from one tunnel to another in a secured manner? So why does we need a TLS connection? Let's first talk about that. Whenever we are making a connection to the server, we are sending sensitive information like my card number, my bank details, and everything. If it is not encrypted, it is going directly into the text format, and in between it can be changed, it can be read, there can be a lot of attacks which can happen on this data, and we want to avoid that. Basically, if we do a HTTP request, then the informations like password, username is just appended to the request and it is being sent. We want to avoid that. Now to avoid that, we came across the TLS connection. So let's talk about how does it work. So there is a client and there is a server. Server has its own certificates which are generated from the private key, and it is being digitally signed by certificate authority. So let's first talk about what is a certificate authority. Certificate authority is an entity which client and server both can trust. So it is just that if the certificates are trusted by the certificate authority, then client will accept it. Client will check whether this is signed by certificate authority or not. So certificate authorities are the companies like GoDaddy, DigiCerts, which provides digital signature to these servers and clients to their certificate. Now let's talk about what happens in a TLS connection. So we have a client, we have a server. Server has its public key, private key, and certificate. Now client will make a connection initialization. It will send a client hello record to the server. So basically what is happening here, that client will be sending a record to the server which we call to client hello. So this is client hello, and it will contain some of the information. Let me write that first. So it will contain the version, that is the highest supported TLS version by the client. Then it will contain a random number which will be concatenation of the timestamp and some random number. Then it will have a session ID which client will generate. Then it will have cipher information, which cipher we are going to use RSA or AES or ECDSA. And then it will have some extension information. It is optional. It is to improve to have additional features into the TLS connection. Now once this record is sent to the server, so server will have some of the extra information. Now those are, server will have the TLS version supported by the client. Server will have the client random number. Then server will have the session ID as well, and will have the cipher information too. Now after this record is being sent from client to server, server will also send a server hello to the client. So it will look like this. It will be server hello, and it will also have the same information. So let me write that again. That will be version, that is, it will be the version which is supported by the server, and we will choose the highest common version supported by client and server. Then it will have a server random number. Then it will have the session ID, then the cipher supported, and then the extension. Now client will also have some of the information, that is the client will have the version information, which is supported by both. Now client will have client random, which was generated by itself. Then it will have server random, which it just received. Now it will have session ID too, and it will have the cipher. So client also has this information. Server will have server random as well, which it has generated. Now let's talk about all these 5 fields. What are those? So I have written here client hello or server hello. It will be same for both. Version is the highest TLS version supported by either client or server. Random will be a 256-bit number in which first 32 bits will be the timestamp and other bits will be a random number. So any record which is 1 second apart cannot have the same random number because the second will keep on changing. Now session ID is generally start from 0, but it can be any random number as well. Cipher will contain the information in the preferred way which is supported by client or either server. So if client support RSA as first choice, then RSA will be there. Then in the second number in the list there will be any other cipher like DES, AES or ECDSA. So it will have a preferred list. Now it will have an extension. It is like any other option. It is an optional feature which will contain an extra information if there is a requirement of additional feature. Now once the server hello is done, server will send the certificates as well. So there will be another record which will be sent to the client, that will be certificates or a complete certificate chain. It will have the public key within the certificate itself of the server. Now client has some more information, that is it has certificates of server and it has public key as well. Once this is done, server will send another record which will be server hello done. So basically server is saying that from my end my hello request is done. So it will be server hello done. So it has sent all the data which needed to be validated. Now client has certificates as well as the public key. So here client will be validating two things. First, whether the certificates are valid or not, and other than that client will validate whether this certificate belong to the server or not. So first let's talk about the first thing. So client will check whether certificate has the validity or not. If it has the validity, it will check the certificate authority information. So it will get the CA from this certificate and it will check in the trusted store of its storage whether it belongs to this or not. So generally certificate authorities which we talked about, CodeAD, ADG certs, those are already installed by OS or or browser into the storage. That we cannot see directly, it is being stored in encrypted way, but those are already there, and with every update of window or mobile update or browser update, those certificates those CA keeps on getting updated. Now we will check whether this certificate which server has sent belongs to valid or trusted certificate authority or not. Once this check is done, we know that the certificates are good. After certificate check, we are going to make sure that this certificate belong to the server or not, that the server is the true owner of this certificate or not. For that, what client is going to do, client is gonna send another record which will be client key exchange. So it will send another record, that will be client key exchange. And in this it will just have a random number which it will encrypt using the public key of the server which it has already received. So what it will do, it will select a random number which is a 48 byte number, to which we will call pre-master key. So here it is, this one. It will be a 48 byte number in which first 2 bytes will be the TLS version and other 46 bytes will be a random number. So it will encrypt it using the public key of the server which it has already received within the certificates. Now what it will do, that it will send this, and we call this particular encrypted record as pre-master secret. So this is being sent to the server. Now server will have pre-master secret, and as well as the client will also have this. So we have pre-master secret here and here as well. Now this pre-master secret at the server side can only be decrypted using the private key of the server. So it will decrypt it using the private key of server, and we will validate, okay, these certificates, like the owner of this certificate is the server only. Once this is done, we are going forward. After this is done, then we are going forward to create the session keys which are going to be used in this TLS connection to encrypt the data. So once pre-master key is available at both the side, we will create another data that will be the master secret key. And how this master secret key is going to be created, I have written here. So we will combine pre-master key with the literal master key, client random and server random. This combinedly will give us the master secret. And since this information, all these 4 items are available at both the side now, so this master secret will be created at both the side. So we will have this master secret key at both the end here. So client also have master secret and server also have master secret. Once this is there, what we are going to do, that with this we are going to create another record that will be combinedly from master secret, key expansion literal and client random and server random again. This record will generate the session keys. How we are going to do that? That with this record we will create a hash and we will pass that hash to a PRF function. PRF is pseudo random function. It is basically, every time we will pass this hash to this function, it will give us a different value. And this these session keys can be uniquely generated only from the same starting value. So if we have the same master secret, key expansion literal, client random and server random, only then this pseudo random function will give us the same client key. So we can infinitely pass this record into the pseudo random function, and we can set a limit. Okay, to get the client key we are going to do that much iteration, and to get the server key we are going to do that much iteration. Once we have the client session key and server session key, what we are going to do, that at both the end we have all these 4 keys because we generated it from the master secret itself. So So here we have two keys of client, which is going to validate the client data. Then we have two session keys for server, and here as well we have these 4 keys. So 2 key here, which is client session key, and 2 keys for server session key. Now we have all these keys, but both the side don't know whether the keys which are generated by client and server are same or not, whether they have generated the same session keys or not, and this need to be validated first before we exchange data. So first what will happen, that client will send a record to the server, which will be change cipher spec, that will be change cipher spec. That is for checking whether the session keys are generated by clients is same as which are generated by server or not. So what will happen here, after sending this record, we will generate another encrypted message or another encrypted data, and we will send it. We will call this finished, that client finished we can say. So it will send, it will be a record client finished, which will contain encrypted verification. This will be the data. Now how this encrypted verification data is going to prove that the session keys at the server sides are also same? Let's first check how this encrypted verification is being generated. So we have master keys at both the side, and we have the client keys and server keys as well. So how we are going to generate this encrypted verification is this way. We will combine all the records which has taken place till now, client hello, server hello, certificate, and server hello done, and client key exchange as well. We will create a hash out of it. Once we have the hash, we will combine this with master secret, string literal client finished, and this hash which we have created. Now we will pass it through a sudo random function, and this will generate that like data which need to be validated, whether the session keys at the client side are same at the server side or not. So how we are going to identify that? This data we are going to encrypt using client session keys. We have client session keys at this end, and we will set this encrypted verification data to the server side. Now when server will receive, server will use these client key to decrypt that data, and it will get some value which is a hash value which was created from all these 5 records, basically, which was created from client hello, server hello, certificate, server hello done, and client key exchange. From all 5, that hash will be generated. So server will also, what it will do, that it will combine all these 5 values, and it will generate the hash for it using the client. It will generate the hash of it, and it will check whether the data which it has received, which is decrypted by the client key at the server side, the hash is coming out to be same or not. If it is coming out to be same, then server verified, okay, the session keys are same at both the side. Now once this is verified, now client also need to verify that whatever keys it has, does the server also have the same key. So for that purpose, server will also send a record which will be change cipher spec. It is basically saying that we have all the data to start sending encrypted data. So it is basically change cipher spec, which is saying okay, we have all the things to start with the connection, and then it will send this encrypted verification from the server side. It will also be a finished record, finished from the server side, and it will have encrypted verification data. How does this encrypted verification is coming? Same way, we will get all those 5 values: client hello, server hello, client server hello done, and certificate and client key exchange. Will create a hash out of it, will pass it to a pseudo random function, and will encrypt it using the server key this time. Previously we encrypted using client session key, this time we will encrypt it using server session keys. Once that is done, it will be received at the client side, and client will decrypt it using the server session keys, which is here, and it will get a hash. Once it will get a hash, it will create all these 5 records and create a hash out of it and check whether this hash is same or not. If it is same, then client also verified okay, the keys are same at the server side as well. Now once all this is done, we can start moving data through this secure tunnel. So basically now we can send the data, encrypt using the client session key from the client side, and using server session keys from the server side. So it will be the data which we will be sending. Encrypted data, and this can be decrypted only through these client session keys and server session keys. Now with this being said, we can always have new session keys. So whenever there is a new connection, suppose it in this way that whenever we are visiting the site and we are logging in, every time we log in we create a session. So these session keys will be generated, will generate a new session keys. Why so? Basically we are generating it through random numbers, session ID, and all this certificate, server hello, hash, and this random function itself is going to change always. That is how we are getting a new session keys always. This is how TLS works. This is how data is being sent in a secured manner from client to server and server to client. Here we can see that the application data will always be secure since it is encrypted by the server's client session keys or server session keys, and it can be decrypted only by those keys which are available at the other end. And one more thing to notice, that these keys didn't travel from one end to another. These are being generated at the server side and the client side. So this is all about TLS. Now let's talk about mutual TLS as well once. So how does mutual TLS work? Let's see the scenario where we need it and why. So TLS works, in TLS only server send its certificate to the client and client authenticate okay whether this is a valid certificate or not. If it is not a valid certificate, client will not go with the TLS connection, it will reject it. Now we want to validate whether it is a genuine client as well or not. If it is connecting to my server, then it is a genuine client or not. Now what is the scenario where I need it? Suppose I have a company where I am connecting to my server and my employees are connecting to that particular server, and I don't want any other person to connect to that. I want only my authenticated client should connect to that. Now if I'm using a TLS connection, then I'm authenticating only the server and I can connect to that. But if I want to authenticate clients as well, then what I need to do, that I need to send client certificate as well to the server, and server will check whether this is signed by a certificate trusted certificate authority or not. So in this case, let's talk about how it is going to happen. One more thing is there, that why not then we have mutual TLS connection everywhere. We can have that, we can, but it is really expensive in terms of the functionality we are getting. When I am visiting a website, simply if I am visiting LinkedIn, then I don't need to validate myself as a client. Suppose 1 billion users are logging into LinkedIn and all of them are having certificates, they are sending it to the server is verifying those certificates. This is a lot of computation, this is really expensive. So we don't want to do that until and unless there is a requirement. So mutual TLS is used in a zero trust scenario where we have no trust over the network and we just want to secure everything. There it is being used. Now let's talk about how does mutual TLS happen. So in case of mutual TLS, we don't have a public CA authority generally. Why so? Because the public CA authority will create certificates for each bike, for each devices, and then all the certificates need to be validated through that CA. Instead, what we have, that we have our own CA, that is, we create our own CA and we store it at both sides, server side as well and the client side as well. So we will have a CA here and we will have a CA here as well. Now we will generate the certificate. So we will generate client certificate here as well using the private key, and certificate which will have the public key. Now when both the sides have the certificates which are signed by the same CA, we will start sending the certificates from one end to end. So the connection will go in the same way. First client hello will be there, server hello will come, server will send the certificate, and then server will send server hello done. After this, what will happen, that client will also send its certificate. So client is going to send its certificate to the server, which will contain the public key of the client, and then we will send the client hello done as well. So we will send another record, that will be client hello done. Now server also have these certificates. So server has certificate of client, and public key of client. It will check whether this has the validity or not. Then it will check whether this is signed by the same CA or not, whether this is signed by a trusted CA or not, and it has the CA, so it will check the CA. Now once this is done, the same process will happen, that the client key exchange and server key exchange, and then same process will follow. And here we have mutual TLS, since server also have validated the certificate of the client, whether those are signed by the same CA or not. This is how we get a mutual TLS connection.